All right, let's talk about the ASVAB General Science Test. If you're getting ready for it, you know that some of the physics questions can be a little tricky. So today we're going to break down heat and thermodynamics piece by piece so you can walk into that test feeling ready to go. And hey, if you are feeling the pressure, that's totally normal. All this talk about heat transfer, energy, and motion can seem a little, well, out there. But trust me, it's a very predictable part of the exam, and once you get the core ideas down, you're going to nail it.
And that's exactly what we're here to do. We've gone through the study guides and pulled out everything you need to know, laying it all out in a super clear roadmap. So, you ready to get started? So here's the game plan. We're going to start with the basics, what temperature actually is and how we measure it. Then we'll get into the 3 ways heat moves around. After that, we'll connect it to the bigger ideas of energy and motion, hit some real practice problems, and then wrap it all up with a quick review. Let's dive in.
First things first, we have got to have a solid grip on temperature. It's really the foundation for everything else we're about to cover. So how do we actually measure this stuff?
Okay, so you're going to see 3 main scales on the test: Fahrenheit, Celsius, and Kelvin. They all do the same job, measure heat, but they use different starting points, mostly based on water. You got Celsius, where water freezes at 0 and boils at 100. Super simple. Then there's Fahrenheit, which you're probably used to, with 32 for freezing and 212 for boiling. And then there's Kelvin. That's the one scientists really love, and we're about to see why.
Now, don't worry, you probably won't have to do these exact conversions on the test. The important thing is to know they're related. But check out that key fact about Kelvin. That's the real game changer. 0 Kelvin is absolute zero. It's the coldest anything can possibly get, a point where all the atoms and molecules just stop moving. It gives science a true absolute starting point, which is just crucial for a ton of physics laws.
All right, so we get temperature. Now let's talk about how heat energy actually gets from one place to another. This is the heart of thermodynamics, and it's essential for understanding things like how a military vehicle's engine stays cool or how protective gear actually protects you. Let's jump in.
So, heat gets around in 3 main ways: conduction, convection, and radiation. You absolutely have to know these 3 for the ASVAB, and more importantly, know how to tell them apart. So let's break each one down.
First up, we have conduction. Just think of it as heat transfer by direct touch. Imagine the big metal engine in a tank. As it runs, it gets blazing hot, and that heat moves right through the metal parts because they're touching. That's why we call metals conductors. But on the other hand, things like the plastic grip or wooden stock on a rifle, those are insulators. They do a really bad job of moving heat, which is a good thing because it protects your hands.
Next up is convection. This one happens in fluids. And remember, in science, fluids means liquids and gases. A perfect real-world example is an engine's cooling system. Coolant gets pumped into the hot engine, and as it absorbs heat, it gets warmer and less dense, so it rises and flows to the radiator. Then, cooler air blows past, cools the fluid down, making it denser, and it sinks back toward the engine to start the whole cycle over. That moving circle, that convection current, is literally what keeps that massive engine from overheating.
And last but not least, we have radiation. Now this one's the weird one. Unlike conduction and convection, radiation doesn't need anything to travel through. No solids, no liquids, no gases. It moves as electromagnetic waves through the total emptiness of space. The heat from the sun getting to us is the classic example. But think about this too. The heat coming off a person or a vehicle, that's also radiation. It's what thermal imagers pick up. And understanding this is also key to how NBC, nuclear, biological, and chemical suits work. They're designed to reflect that thermal radiation away.
Okay, so we've got temperature and the 3 ways heat moves. Now let's kind of zoom out and see how these ideas fit into the bigger picture of energy and motion. This is where it all ties together.
You know, in physics, energy usually shows up in 2 main flavors. First, you've got kinetic energy. Super simple. If something is moving, it has kinetic energy. That's it. Then you have potential energy. This is stored energy. Think of a cannonball sitting at the top of a castle wall. It's not moving, but it has the potential to do a lot of work because of where it is. That's potential energy.
And you really can't talk about motion without bringing in the man himself, Sir Isaac Newton. His 3rd law is something you will absolutely see on the test. It's a fundamental truth of the universe. Forces always come in pairs. You push on a wall, and the wall pushes back on you with the exact same amount of force. It's how rockets fly, and it's even how we walk.
All right, enough with the theory, right? The absolute best way to make sure all this is sticking is to actually put it to the test. So let's run through a couple of practice problems you might see on the ASVAB.
Okay, here's our first one. Take a second and read it carefully.
The key word here is solely from motion. What do you think the answer is?
If you picked A, kinetic energy, you are spot on. By definition, kinetic energy is the energy of motion. See, this is a great example of why just memorizing those core definitions is so powerful. Sometimes that's all it takes to get the point.
Let's try one more. This is a classic application question. So think about what's happening. You have an action, Sarah pushing forward, and then you have a reaction, the boat moving. Which one of Newton's laws does that sound like?
And the answer is D, Newton's third law. Her pushing forward is the action. The boat moving backward is the equal and opposite reaction. It's a perfect, real-world example of that law in action. Fantastic job.
Phew, we have covered a ton of ground. So before we wrap this up, let's boil everything we've talked about down to the absolute must-know points for test day.
Okay, here's your final review. Remember, heat is just energy on the move, always going from a warmer thing to a cooler thing. You have to know the three ways it moves: conduction, touching; convection, flowing; and radiation, waves. Get comfortable with the three temperature scales. Know the simple difference between kinetic energy, which is motion, and potential energy, which is stored. And finally, remember that Newton's laws are the bedrock for all questions about force and motion.
You've put in the work, and you've seen how all these physics concepts fit together. You are taking a massive step toward acing that general science section. Just keep on practicing, stay focused, and you are gonna do great. Thanks for watching.